Look at this blank page transforming into a dense grid, with a glowing path tracing a route from the entrance to the exit. This is the output of the MiniWebtool Maze Generator. This tool generates custom layouts for classroom worksheets, tabletop games, or interactive digital presentations. It provides two primary outputs: a print-ready vector file for physical handouts, and a dynamic animated solution for digital displays. In this guide, we will cover how to configure these grids using specific mathematical logic to ensure that every puzzle you generate is solvable. The interface includes input fields for width and height. You can set your grid anywhere from a compact 5x5 up to a maximum of 101 by 101 cells. For the most consistent results, it is recommended to enter odd numbers, such as 21 or 31. Using a depth-first search algorithm, it carves the labyrinth by alternating cells and walls. This requires an odd-numbered grid for a proper border, creating a perfect maze with no loops. Even at a dead end, there is exactly one valid route between points. If you enter an even number, the tool will automatically adjust your input to the next valid odd number to preserve the structure. The odd number rule isn't a random restriction. It is the structural requirement that ensures the resulting puzzle is mathematically sound and solvable. Below the dimensions, you will find drop-down menus for the start point and end point. These allow you to anchor the entry and exit to specific corners or place them randomly along the edges. Regardless of where you place these markers, the logic we established in the previous step ensures a path always exists between them. You can also customize the appearance by selecting colors for the walls, the path background, the start and end markers, and the solution line. When choosing your colors, prioritize high contrast. As this comparison shows, using distinct tones for the walls and the path makes the maze much more accessible for a player to navigate. By combining intentional routing with high contrast styling, you turn a mathematical grid into a functional game. In the advanced settings, you can configure the width and playback speed of your animated solution. The fast speed profile utilizes fewer frames, which results in a smaller file size for the final download. The slow profile produces a smoother animation by using more frames, but it will lead to a larger file size. For large 101 by 101 mazes, it is generally better to use the fast setting to keep the file size manageable. Once your settings are dialed in, click Generate Maze to see the results in the tabbed Output section. You can then download your maze in three formats. The PNG is a standard raster image, suitable for most web uses. Contrast that with the SVG format. While a PNG pixelates when enlarged, an SVG is a vector format that scales to any size while remaining sharp. This makes SVG the best choice for large physical projects, such as posters or printed workbooks. Finally, the animated GIF option creates a video that traces the solution path in real time, which is useful for demonstrating the answer to your puzzle. Choosing the right export format ensures your maze remains legible, whether it's printed on a page or viewed on a screen. You now have two distinct assets: a high-resolution puzzle file for your audience to solve, and a dynamic animation showing the solution. These can be deployed immediately. You can insert the SVG into a document editor for a physical worksheet, or embed the GIF into a presentation to show the solution loop. Since the tool uses procedural generation, you can click the Generate button at any time to produce a completely new variation with the same settings. By mastering these configuration steps, you can now generate an endless supply of custom, solvable logic puzzles for any project.